What's going on, everybody? My name is Mike.
And I'm Rory.
And this is Actuonics. This video is going to be a brief tutorial on setting up and configuring our LAC board to work with our feedback, position indicator, and potentiometer switch. Now, a quick safety warning. Before we begin, please note that the LAC board is static sensitive. Make sure your workspace is static safe before removing the board from its static bag, or you could damage the board.
With your LAC system, you'll need 5 main components. Number 1, of course, is the LAC board itself. You'll need the position indicator display, a potentiometer for input control, and a power source, which can either be one of your own power supplies you already have of the correct voltage and current. You can use one of our Actuonics power supplies. We have 12 volt DC and 6 volt DC. And if you happen to be running one of our 6 volt units, you can use the battery holder that comes with the linear slide potentiometer. And finally, you'll need one of our -P type actuators, which are the units that have the built-in position feedback. Position indicator display can be used regardless of which input method you choose for controlling the LAC.
So we'll walk you through some basic setup steps. First step, you're going to want to make your initial connections. So with power disconnected, connect your actuator to either the screw terminal header. Now this is what you're going to use if you're using an actuator from another manufacturer. You're going to want to wire it directly into the screw terminal header. The pin header, where you're going to want to align the yellow wire with the pin labeled yellow on the LAC. This is what most of our actuators are going to use. Or if you're using a PQ12, you're going to want to use the PQ12 vertical connector. For all wired P-series actuators, the wire colors are standardized. The yellow wire is going to be your feedback reference, or P negative. Your black wire is going to be your motor, M negative. Your red wire is going to be your motor, M positive. Purple is your position feedback, and orange is going to be your feedback reference, or P positive. Step 2, power connection. Connect your power supply, matching your actuator's voltage rating. Alternatively, you can use the included battery holder, as Rory mentioned. This is only for 6 volt actuators. An important point to remember is you never want to connect more than one power source. Only use one power source at a time. The LAC board's light will only illuminate when it has a recognized input signal as well as an appropriate power source. Step 3, potentiometer control. Connect one of the potentiometer reference pins to the LAC screw terminal, P positive, and the other to the P negative. Connect the potentiometer wiper pin to LAC terminal VC. You will need to solder wires to the slide potentiometer to make these connections. Step 4, position indicator display. To connect the display to the LAC, you'll need to cut off the connector, connect the red wire to the LAC terminal P, connect the black wire to the terminal negative, connect the white wire to the terminal positive. The potentiometer on the back of the position indicator can be adjusted to fully light the LEDs at the correct actuator position. There's also a jumper behind the indicator. Remove it if you want to change from bar mode to single LED mode.
And I'll go through some of the configuration options. Now you can manually adjust several of these settings on the LAC itself. The LAC features 4 adjustable potentiometers. They're the blue-colored units that have a small screw on the top that you can turn clockwise or counterclockwise. The first one is the retract limit. You'll find it near the USB connection. This controls how far the actuator can retract. Fully clockwise allows maximum retraction. Counterclockwise reduces this retraction distance. The next potentiometer is the extend limit, which is further from the USB. This controls how far the actuator can extend. Again, fully clockwise will be your maximum extension, and turning it counterclockwise will reduce extension distance. The third pot is the speed control. This adjusts how fast the actuator moves. Fully counterclockwise will be 0 speed, and fully clockwise will be maximum speed. Using this, you can find the right balance for your application. The fourth is the accuracy setting. This determines how precisely the actuator stops at its target position. More clockwise will be higher precision, but if you turn it all the way, it may become jittery and you'll have to back it off slightly. This helps eliminate unwanted oscillation around the target position. Now this is an important note here. After adjusting any of the potentiometer settings, you have to cycle the power before these changes take effect. This is removing power from the LAC and then reapplying it.
So next, we're going to quickly go through a couple troubleshooting tips with this setup. An important thing to note with the LAC board is the light is only going to illuminate if you have both a power signal and a recognized input signal. So if your input's not right, or if something's off there, it will not illuminate. So you got to make sure we have both those things in order to get the light on the LAC board. If the actuator won't move, you'll want to check if your limit settings overlap on your two extension and retraction potentiometers. Verify your power supply matches the actuator's voltage rating. This is really important. If you're using a 6-volt actuator, you have to use a 6-volt power supply, and you can always check your connections, make sure they're secure. If you're having any more troubles beyond this and you've performed all these troubleshooting steps, feel free to reach out to support at actuonics.com and we can give you a hand.
The LAC board is a simple, inexpensive way to add more functionality to your actuator. This is just one of the possible setups using an LAC board. We will cover more of these applications in future videos. For more details, information, visit actuonics.com or refer to your product documentation.